Hello everyone. This is Sai Nanshu and my teammate Tejaswini. Today, this video is about the demonstration, which is a continuation of our presentation. And now over here, I'll show you our playground scripts, which is our iPad in the notebook, where we generated all the plots related to our project, trained our models, and saved the models, which will be later used in the Flask application. So a quick run through the playground that we have is we have all the imports and then we read the data sets. This data set is a KitSan data set which is publicly available, and we use the 3-second CSV files to go through the data set. And then comes the EDA, where we check whether the data sets are balanced or whether they are filled with zeros or NaN values. Luckily, the data set was already good and we had to do less of reprocessing steps. And then comes the sample data visualizations, which these are the plots we used in the presentation too. This plot describes about the correlation between how the features we are going to use later on to train the models are. And then this plot shows the tempo or the BPM beats per minute for any genre. And as you can see, most of the genres have the BPM range pretty close. So relying solely on BPM is pretty hard, as all the genres usually have their BPM between 100 and 150 for the median. And so that's why MFCCs are necessary. Then comes a simple scatter plot for the PCA, principal component analysis, where for each and every genre, we have their points plotted on the screen. And depending on the cluster, you can have different algorithms working. But as there is no clear separation between the sectors or the clusters, we can't use a simple machine learning model like SVM or a logistic regression. So we had to use our neural network to train our model. Then comes our model itself, which to build we used again TensorFlow. And then we loaded up the genres and then saved it in a JSON file. So for our features, so the features that we used is MFCC again, because depending on like the core features like the beats or the BPM or like basic tempo or the keys used wasn't just enough. And then once we have the JSON ready, we load it and then we created our model. So we used, again, as I said, like the TensorFlow kernels to create our CNN model. And then we compiled our model using Atom Optimizer. So this is how our model overflow looks like. Um, and we added a lot of dropout layers and batch normalizations to prevent the overfitting. And this resulted in this particular output, where you can see like we have trained for around 31 epochs, and then we gave an early stopping because the accuracy was good enough, and we didn't want our model to be over fitted. So um, with that accuracy, this is the plots that we got for the accuracy versus train accuracy and test accuracy, and how the error was dropping. Um, then finally, this is how our metrics look overall span of different epochs. And then, yeah, when we tested it on the test set, which we separated at the beginning, we had an accuracy of 72%, which again might seem like a low number, but our main goal was not to have an high accuracy model. Our main goal was to have a model which is reliable in real world and which could adapt. So this accuracy is just a metric for us and not a deciding factor whether to use this model or not. Because we have used good features, so and when tested on real world, it works fine. And then we save the model as a H55. Then finally to test it, we had the same group that we separated at the beginning. But apart from that, we even have the an additional files that we downloaded from Google, where we have the real genre identified preset and then a predicted genre. So when we gave it a try, we found out that the predictions were up to the mark, and the accuracy score that we saw above wasn't really an effect on this. And then finally, we have a few more additional plots that will be added in the report, but we couldn't show it in the slides. We already showed and discussed about the confusion matrix, where we saw that the diagonal elements, which usually are the true positives, have a really decent accuracy scores, except for the jazz and the classical. But we had to stop it early to prevent overfitting. And then comes the F1 scores, which again, as expected, would be really high and really good for majority of the classes. And then the top K accuracy, which means that the prediction, instead of just one, if you predicted three, if you predicted five, what would be the accuracy? As you can see, the accuracies have improved significantly. So um, that's something noteworthy. And then the ROC curve, which we're getting included in the PPT, where the area under a particular plot shows how well the feature is working for that particular prediction. And every single feature has its area high and way above the threshold line. And this is just a simple plot between how confident is that during a prediction, whether it's a correct or wrong prediction. So you can see like the wrong prediction's confidence is really low. I mean, the prediction confidence is really low, so it makes sense that it's a wrong prediction, and that means the model is on a average really good. Um, and this is again included in the plot where there's a segment-wise predictive class where at a given for a given uploaded audio file, it tells how at what point of the segment it identified the particular class. So over here we chose the classical for this example, and yeah, it was able to predict it correctly. And then at the end, we have the calibration on how reliable the particular plot, the particular model is. So if every single point aligned on the orange line, that means the model is overfit. But luckily, we don't have an overfitting problem, but the points predicted lie closely around the line, which means that the confidence is really good and the accuracy is also well balanced. Moving on to the Flask application, over to Teju. Tejaswini.
Okay, hi. So the Flask app is the bridge between the user and our trained model. The user uploads a audio file in the browser. Flask receives it and extract the MFCC's features in the same way we created the dataset, and then feeds those features to the CNN model and then returns the predicted genre with probabilities. So basically, in this front end Flask model, what we have done was we'll upload. First, we uploaded a button, a play audio preview, and a prediction button, and then the Flask saves a files temporarily, and then audio. So we have done an audio loading. Uh, where it checks the format, is it in a wave or is it in a mp3, and checks duration, uses try expect to avoid crashes for corrupted files, and then the MFCC's extraction inside Flask is the most important part. The Flask feature extraction must match your uh, our training pipeline. So we load our audio at a fixed sample rate, and then split into segments, compute MFCCs for each segment, and ensure the uh, padding and truncating are correct, and normalizing normalization is done, is used in the training. um, and then we have the CNN model interface. Flask loads the saved model at the start, and then it requests and then the multiple segments, like either average probabilities across segments or majority voting for the final genre. What is the genre we get majority voting for each of it, and then we'll see the results on the UI of the website. So we'll head to the website. Here we can
Yeah,
we
let's
can
see here.
upload Here we can upload a music file. It can be WAV or MP3. Here an example of the audio what we have given. And when we click on predict, it computes and give us a result with predicted voting percentages. Like the top prediction is metal for 97%, and this is our results. Thank you.
Um,